Okay, bismillah. Okay, so last time we were speaking about the unit 7 last parts, which is the solubility equilibrium. And we also said that we'll be explaining the common ion effect. So let's just review what we took last time. Last time we said that the solubility is the concentration of the ions. Is actually the concentration of ions inside the solution. Of ions inside the solution. So if you have a solution of silver chloride and you want to know its solubility, so you need to know what is the concentration of the silver ions and the chloride ions in this solution. Silver ions and chloride ions in this solution. The maximum amount of the silver or chloride ions that can dissolve in a certain amount of water at a certain temperature, this is the solubility. So this is the maximum amount that you can dissolve from this salt inside a certain volume of water at a certain temperature. So for example, if I'm saying that sodium chloride is highly soluble, I know that it can dissolve up to 36 grams of sodium chloride inside 100 ml of water, while something like lead chloride, for example, this is only can dissolve 0.99, so only 0.99 grams of lead chloride inside 100 ml of solution, inside 100 ml of water. Okay, then we talked about the solubility product, and we said that the sodium chloride, we can find the solubility product the same way we are finding the equilibrium constant. So it's equal to the product's concentration divided by the reactant's concentration, and all of them is powered to their coefficients. So this one is powered to the coefficient, and this also is powered to the coefficient. So if you have a general equation in which for example, a silver sodium chloride is dissolved into Na plus and Cl minus, this is aqueous, and this is aqueous. So this means that the Ksp, which is the constant for solubility or solubility product, is equal to the Na plus concentration multiplied by the Cl minus concentration divided by the NaCl concentration. Since every one of them has a coefficient of 1, so they are all powered to 1. If I have something which is less soluble, it will also follow the same rule. It's also going to follow the same rule. This will only apply for the gases, and the same way in equilibrium we are applying it for gases, here will apply only for the aqueous solution. So if I have something like the carbon, which is solid, or C, which is a solid substance, not carbon, any solid substance with a simple C, and it's broken down into A, X, and B, its number of moles is B, and Y, X and Y is the valency. So this is they are the valency, X and Y, and they are both aqueous. So in this case, the KSP will be only for the products because it is A, and then to the valency of X, and then power to A, and then multiplied by B, and the valency is Y minus, and power to the P because the P is its coefficient. So this one, the coefficient for it is P, and coefficient is P, and the coefficient for this one is A. So it will put it to the power. The C will not be mentioned in the equation. So this is not mentioned in the equation as it is in a solid state, so we will not mention it. So the equation will be like that only. Then we said that we can, because we don't know how much of this aqueous solutions or these salts will dissolve, because they are all are weak electrolytes. So I have two types of electrolytes. I have the strong electrolyte and the weak electrolyte. The strong electrolyte and the weak electrolyte. The strong ones, I know they completely decompose. So I know that, for example, if I put HCl, so if I put HCl and HCl breaks down into H plus Cl minus, I know that all the quantities that I will put in the solution will dissolve. So 0.1 moles dissolve to form 0.1 moles and 0.1 molars. And if I have 0.2, it will also break down into 0.2 plus 0.2. So the whole amount will be dissolved. The initial amount is 0.2 and the final amount will be 0. Why? Because all the amount will be broken down. And if this is the initial amount is 0 and 0, this will be broken down into 0.2 and 0.2 also. The electrolytes, which are weak, will be different, because if I have, for example, lead chloride, and it is broken down into lead and the two chloride ions, I don't know how much will be broken down. So I don't know what is the amount that will be broken down. So if I started with 0.1, I don't know how much from this one will be broken down. So if the ratio is 1 to 1 to 2, I don't know. This is initially 0, but how much of it will be broken, I don't know. So it is X. And since it is decreasing, the reactants concentration are decreasing, it will be minus X. And then the amount that's formed from the products also is going to follow the ratio. The stoichiometry ratio is 1 to 1 to 2. That's why I will have to follow this rule. So it will form plus X here and plus 2X here. So this ratio has always to be followed like that is X, because this one is 1, and that one is X because this one is 1, and this one is 2X because it is 2 in the number of moles in the coefficient. So I will do the equilibrium. How do I do the equilibrium? I just add these two together. So 0.1 minus X, and this one was 0, 0 plus X, so it is X, and 0 plus 2X, so it is 2X. If you want to find what is the constant, it will be Q, as the equilibrium, it will be KSP. So KSP is equal to the products, which is K multiplied by 2 minus X, and then divided by 0.1 minus X. So since this one is, sorry, this is x multiplied 2x, sorry, 2x. And this one, since it's the coefficient 2, so it is powered to 2. So x multiplied by 2x squared divided by 0.1 minus x. And this is how I will get the products divided by the reactants. But this one, Mister, is a solid. So this is solid. So what should I do? I should not mention this one here. So I will not mention this one in the equation. It will be only products without the reactant. So it is x multiplied by 2x squared. And that's equivalent to 4x cubed. How did we get this one? The 2 is squared, it will give me 2. And then I will add these two together, x to the power of 1 and x to the power of 2. So they will become 4x3. So every time I have this one, in the form of 1 to 2, I can find it as 4x cubed. Okay, so 2x squared. And then x, so it will be 4x cubed. In the exam, he will call this x the concentration, or he will call it solubility. So I can call it concentration, or I can call it solubility. Concentration or solubility. You can remove x and put s instead. So any unknown symbol can be placed. This is s, this is x, it can be any of them. So if he give me the KSP, I can find the KSP by if I'm given the solubility, and the opposite can happen also. And also the opposite can happen if I have the KSP, I can find the x. How do I do that? So how can I do that? I will just put K is equal to radical 3 of KSP over 4. How did you do that? I divided both of them by 4, and then I got radical 3 for both of them. احنا عملنا summary المرة اللي فاتت, and then we said that we can, instead of writing the ice table every time, so instead of writing the ice table every time, I can just divide my equation into two types. So instead of making the ice table every time for the solubility product, I can just memorize it. So I can just say it depends on how your salt is going to break, how your salt is going to break. If the salt is divided into, so 1 mole of it is divided into 2 moles, 1 and 1, it is different from if the salt 1 mole is going to break into 1 and 2, and the third one, if the salt is going to break into 1 and 3. So if the ratio is 1 to 1, then what did we say? What was the number last time? The equation is telling me if it is 1 to 1 to 1, then KSP is equal to what? Simply x squared or s squared. So if you have the solubility, you can find it by, if you have the solubility, you can make it to the square, so then you will find KSP. And if you have the S and you want the KSP, so KSP is KSP is equal to S squared, and S is equal to the radical of KSP simply. Right. In case of 1 to 2, لسه قايلين الريشيو بتاعت 1 to 2. What is the ratio in case of 1 to 2? يا مريم, it will be KSP is equal to what? This is the one. So it will become KSP is equal to S 4S cubed. And if it is the ratio 1 to 1 to 3, so it will be 1 to 1 plus 2, 1 plus 3. So the KSP is equal to 27S to the power of 4. And here S is equal to radical 3 KSP over 4. and here S is equal to radical KSP4 over 20S, over KSP over 27. So this is a summary of what we said last time. I think Yasin already attended this one. And then we said that I have 3 cases for solubility. I can memorize the equations, so I can memorize the equations. Or if you want to make the ice table, it's still okay. Right. The other type of questions, when we said if we want to know, am I at solubility point or no? Am I at equilibrium? Or I'm moving more towards precipitation? Or I'm moving more towards the solution? So I have 3 cases. Every time I'm checking the concentrations, I have 3 cases. I might be either at equilibrium, and if you are at equilibrium, this means that the rate of precipitation is equal to the rate of dissolution. So rate of precipitation is equal to the rate of dissolution. And if you have a faster rate of precipitation, you will be moving towards what? Backwards. So faster rate of precipitation. So is it the forward more or the backward more, Yasin? That's the rate of precipitation. This is if Q equal to KSP. When if Q is more than KSP, here Q is less than KSP. So here you are moving more
to the left.
To the left, to the backward. So you are moving towards the precipitation more. Because here this is a solid, for example, and you are moving more towards the precipitation, towards the backward direction. So you are making more of the precipitate more than you are making of the soluble. So you are making more of this precipitate. While if you are going forward more, then the faster rate is for the dissolution. It's faster than precipitation. So you are moving towards the right or the forward. And in this case, you are making more of the products, and the products are the soluble ions. So the products will be the soluble ions. Like, for example, I have B aqueous plus C aqueous, for example. So you are moving more to the right side, and you are making more of the products. If they are both equal, then you are at equilibrium where neither of them are equal. Okay. احنا قلنا الكلام ده المرة اللي فاتت and just revising on it now, but we need to answer more questions about it. So let's see. Need some practice answer. So here at 25 degrees Celsius, he has to define the temperature every time. The value of KSP for SRF2 solid is 4.3 multiplied 10 to the power of -9. Calculate the molar solubility. So again, I'm saying when he says molar solubility, or he says solubility, or says concentration, he is all meaning the S or the X, which is the unknown solubility of SRF2 in a solution of 0.050 molar Kf at 25 degrees. No, this is, we still did not take this one. Sorry, I'm very sorry. This one we still did not take. Yeah, this is a more simple one. So it's just simply asking if I have these three compounds, FeCO3 and NiCO3 and PbCO3, and he's giving the KSP for everyone. This is 3.1, 10 to the power of -11. This is 1.4, 10 to the power of -7, and 7.4, 10 to the power of -14. So which one will have, so I need to arrange them in increasing order. So increasing order of solubility. So which one will be the least soluble ammonium and which one will be the highest soluble for these three? He is giving the KSP of everyone at the same temperature.
The iron carbonate.
So iron carbonate will be the least soluble,
The most soluble.
the most soluble. Which is the biggest number here I have?
NiCO3.
Yeah, NiCO3. So NiCO3 is the biggest number. So it has the highest solubility, right? Highest solubility. And then in the middle there is FeC, iron carbonate, and then the lowest one will be the lead carbonate. So the more I have the solubility product, the more the solution will have solubility, of course. So if I have a solution here, Fe3 plus and SCN minus gives me FeSCN plus. This is the famous questions about the iron arsenic. So one. This is a delta H at -0. He's saying that this solution is colorless and this solution is dark red. So we mix the two solutions together. So mix FeNO3 aqueous solution plus KSCN aqueous solution. And which of the following predicts what will result? Predicts what will result. I have four options here. The first option is telling me that the mixture will be less red, will be less red. So what did you add, Yasin? I added iron nitrate and KSCN on this solution. And I want to see what happens. Mixture will be less red. Kc will decrease. This is the first option, will decrease. Number B, mixture will be less red also, but this time Kc will increase. And then number C is telling me that mixture will become more red and Kc decrease. And last one saying mixture will be more red and Kc will increase. Okay. So let's see what happens here. See, when you add KSCN and iron nitrate to this solution, and which one, where do you expect it to go? To the right more, to the left more?
To the right.
I added iron nitrate and KSCN. صوتك مش واضح يا ياسر.
Oh, it's gonna go to the left.
Why? But it will go to the left. Why?
عشان if you mix الاتنين دول it's gonna form iron cyanide.
FeSCN.
Oh.
Okay, and then when it forms FeCN, what happens?
Gonna increase the concentration of the product, so it's gonna have to decrease it.
So it will go. So it will become less red, and Kc. What will happen to the Kc? Does it increase or decrease?
So
which one concentration will increase? The reactants or the products?
reactants.
So reactants
يبقى decrease.
يبقى decrease. So الKC بتساوي ايه؟ البرودكتس over reactants, and you said the reactants increase, so
the Kc decrease.
Kc will decrease. So your option is option less red, and Kc
will decrease. ده صح.
Yes, this is the correct answer. You will go to the left more, and Kc will decrease. So how this is happening again? We're saying that when you add SCN, FeNO3 with KSCN, you will form FeSCN2+, and this one increases the concentration of products, so the reaction will try to go left more to balance this equilibrium, so it will go more to the left, so means that the reactants will be more and the products will be less. And since you are increasing the denominator and decreasing the numerator, so the number of the Kc concentration, the Kc value will decrease because you are increasing the denominator only. So that means that it will go left and the Kc will decrease. That's a perfect answer. Okay. So I have one more question, which is saying that I have a few drops of HCl 0.1 molar HCl aqueous solution added to solution at constant temperature. Solution دوت موجود فيه ايه؟ inside a beaker، والبيكر ده فيه 1 liter solution of nickel hydroxide. So I have nickel hydroxide 1 liter, and then I have added few drops of 0.1 molar HCl to the solution. What will happen to the solution? The first option is that the molar solubility, few drops at constant temperature. So he's asking specifically what will increase. What will increase in the value? Is the molar solubility going to increase, or amount of nickel hydroxide is going to increase in beaker, or the KSP is going to increase for the solution, or the pH of the solution is going to increase? So which one do you think, Miriam, is going to increase of these four? If I added some HCl, few drops only from the HCl to this solution.
KSP.
KSP, but why will the KSP increase?
It becomes more soluble.
Okay, but why it becomes more soluble?
The HCl is very soluble.
HCl is what?
It like has high solubility.
Okay. So then Okay, let's see what our solution contains, ya Miriam. What does the solution contain? It contains nickel ions and it contains hydroxide ions. When the HCl goes to the solution, it forms H plus and Cl minus. The H plus and Cl minus reacts with what? With the OH minus. Huh? The H plus is going to react with the Cl minus and form water. This is like a neutralization. So acid and base, this HCl reacts with the OH and forms water. So what happens to the concentration of hydroxide ions? It's going to decrease because the H plus is absorbing all the OH minus. It can absorb and it decreases the OH minus. Even the few drops, it took only a few drops. So it's going to decrease the OH minus concentration. What happens when you decrease the OH minus concentration? The solution will try to do the opposite. So solution have NiOH2 giving us Ni2 plus and 2OH minus. And you have decreased the OH. So the solution will try to it has decreased it, so it will try to increase it. So it will move to the right more. If you move to the right more, then you are moving towards the aqueous, while you are moving towards the solid, yeah, Miriam. If you move to the right more, you are moving towards the aqueous more, so, and the solubility will be more, it will be more soluble. So why did the KSP does not increase also? Why did the KSP? The only thing that's going to affect the KSP is the temperature. Do you remember Yasin we said why this is happening? Why is the temperature only بتأثر على KSP?
Because it doesn't have a reverse reaction.
So it is a reverse action. So I have cancelled what I have done. What did you do? You have decreased the concentration of OH minus. What will the system do? It will increase it back again. So I have decreased it. The system has increased it. So the system has balanced what I have done. يبقى انا ما عملتش حاجه في الكونسنتريشن في الاخر. يبقى الكي اس بي في الاخر بتاعي is the same. لكن the reaction is moving to the right more, is moving forward more. يبقى solubility, so moving towards the solubility اكتر. Rate of solubility is faster than the rate of the precipitation. لكن في الاخر الكي اس بي for the solution it will not change. So please memorize this one. The only factor that's affecting the KSP is the temperature. So temperature is the only factor affecting the KSP. And since he said here at constant temperature, he did not change anything of the temperature. So there is no effect. Only the reaction is moving now more to the forward. So the solubility is going to increase more. The same when we said that the Q is less than KSP. So since Q is less than KSP, since I did not reach the KSP, the reaction tries very hardly to go towards the equilibrium. So it moves forward more and the solubility will be faster than the precipitation. So I have here carbon monoxide reacts with bromine to form COBr, and this is the K pressure بتساوي 1.4 multiplied 10 to the power of -5 at 410 Kelvin. For the reaction system represented above, the initial partial pressures are partial pressure of CO is equal to 2 atmospheric, PPr2 is equal to 2.5, and PCO PR2 is equal to 0.010 atmospheric pressure. So if I reach equilibrium at 410, what is going to happen out of this? So is it that more CO and PR2 will form, and it is because QP is less than KP? Or is it that more CO and PR2 will form because QP is more than Kp, or is it that more COPR is going to form? Because QP is less than Kp, or is it that more COPR2 will form? Because QP is less than Kp. Which one do you think is going to happen? So I have here 2 moles of the first one, 2.5 moles of the second one, 0.0 moles of the last one.
بس المولز ولا pressure؟
I have pressure. I said moles, it's pressure, sorry, atmospheric pressure.
أنا مش فاهم السؤال الصراحة.
So he's saying I'm going to move to the right while I'm going to move to the left. And why is that? But this is what he is saying. Are you at equilibrium? No, I'm not at equilibrium, or I am at equilibrium. Or if you are not at equilibrium, you are moving forward more or backward more. He has given the pressure.
Okay.
So I can just calculate the pressure and see Q and know if I'm at Q or less or more.
We're moving to the backward direction.
Okay. How much did you calculate that to be?
2 times 10 power of negative 3.
So 2 times
10 to the power negative 3.
negative 3. And this is less than or more than the Kp is more than 1.4 10 to the power of negative 5. So Q is more than K. So it will be moving more towards the forward ولا
backward.
ازاي backward؟ احنا قلنا ايه؟
Yes, because Q is bigger, so.
برافو. So it's going backward more because Q is more than K. So the reaction will form more of the CO and PR2. And we said the QP is more than TP. So this is the second option. Huh? Okay. We'll take our first break today for 5 minutes and then we'll be back at 8. Okay, the most important part that I'm having now in this chapter, and it's totally new, the common ion effect. So common ion effect. So the common ion effect is that when you have a solution that already have an ion, and then you add another solution with something which is common between both of them. So let's see this one. I have a saturated solution. I have already a saturated solution. So I have one beaker which contain a certain salt, and it's already saturated. So it has the maximum amount. You cannot have any other amount dissolved in it. And you add another salt to it. And this salt contains an ion which is common between the new one and the old one. So I have a solution saturated here made of silver chloride. So we have silver chloride solution here. And then this AgCl dissolved, so it formed Ag plus and Cl minus. والدنيا saturated اساسا وبايظه ومفيش مكان تاني خالص. And then you go and add a solution of potassium chloride to it. So you add some potassium chloride. So what is going to happen? This potassium chloride will have an excess of the Cl. So I have already a common ion here, which is Cl, which was already present in the silver chloride solution. So the chloride is our common ion. So what is the common ion here? The chloride. And then the Cl concentration is going to increase. So this will increase the Cl concentration. AgCl forms Ag plus and Cl minus. So like we did before, the Cl concentration is going to increase. So what is the response from the system? The system will try to form more of the AgCl. So it will go to the left more. So it will form a precipitate of silver chloride. هو اساسا الكي اس بي بتاعت السوليوشن is very low ومش ناقص اساسا والسوليبيليتي بتاعته قليله جدا. So you put more of the Cl minus, you put more of this common ion. So it moves to the left and the solubility decreases, it moves towards the precipitation. So I have an example here. I have an example. I have a solution of calcium sulfate, CaSO4. Will form or not. So will precipitate. Will calcium sulfate precipitate form of not if mixing saturated solution mean 1 multiplied 10 to the power of -3 of calcium sulfate plus 1 multiplied 10 to the power of -3 1 multiplied 10 to the power of -3 molar of sodium sulfate. يبقى أنا عندي saturated solution من الكالسيوم sulfate. So this is calcium sulfate saturated solution. And then I'm gonna put on it some of the sodium sulfate. Sodium sulfate is going to make sodium and sulfate ions. So it will increase the concentration of the sodium ions in the solution. And then that will make the solution goes to the left. So it will form more of the precipitate. But is this going to happen or no? علشان أعرف الكلام ده لازم أبص على نفس الإيكويشن هنا تاني. Is it going to be equal ولا is it going to be more ولا is it going to be less? So زي ما قلنا المرة اللي فاتت. Is Q is going to be equal to KSP ولا Q is more than KSP ولا Q is less than KSP. If it is equal, then we are at equilibrium. If it is less, then we are moving towards the solubility more. If it is more, then we are going towards the precipitation more. So let's see how to answer this one. So this is the equation that we are talking about. That's calcium sulfate solid forms calcium ions and sulfate ions. Where do I get the calcium ions and the sulfate ions from? I get the calcium ions and sulfate ions from the two solutions that I have. Right. Let's see, Yasin, how this answering differs from the other solution. Here, I did not start with anything initially, and I still don't have anything. So this is no solubility. I have nothing from the calcium or sulfate yet. Then some of the amount is going to decrease. So it will be a minus of the S, and this is going to increase S, and then S here. And then I'm gonna see what is the concentration that I have. He's saying that I have a concentration already of calcium sulfate. What is the difference between these solutions and the ones that we are having before? And then already I'm having some solution of sulfate. So I'm already having some solution of sulfate. يبقى أنا عندي الكونسنتريشن بتاعي هيكون كام؟ 5 ب 10 to the power of negative 4. So what is the number? 5 ب 10 to the power of negative. صح؟ And this is KSP is equal to, we mentioned this one. KSP equal to 2 multiplied 10 to the power of negative 5. And this is 2 multiplied 10 to the power of negative 5. And he said that already I have a sulfate, which is 1 multiplied 10 to the power of negative 3. So this is already 1 multiplied 10 to the power of negative 3. Did you get meaning already? Where did this come from? This one come from the sulfate solution at the beginning, 1 multiplied 10 to the power of negative 3. And this one is 1 multiplied 10 to the power of negative 3. Yeah, like we did last time. Okay, so then I have the concentration of sulfate, but what is the concentration of the calcium ions? What is the concentration of the calcium ions? Mr. Concentration of the calcium ions is coming, our number of moles of the calcium ions is coming from the previous solution, and it's placed in a new solution. So what will be that one? It's equal to 1 multiplied 10 to the power of negative 3 divided by 2. So it is 1 multiplied by 10 to the power of negative 3 divided by 2. Why? Because the volume has increased to the double. So it is the volume of this. It's better to write the whole question again from the beginning. So predict whether a precipitate of calcium sulfate will form if a saturated solution of 1 multiplied 10 to the 3 molar calcium sulfate is mixed with equal amount with equal volume of 1 multiplied 10 to the 3 molar of sodium sulfate. So this is the first test tube. It contains calcium and sulfate ions, contains CaSO4, contains calcium ions and sulfate ions. This is the second test tube. It contains sodium sulfate, so sodium ions and sulfate ions. How many moles are there? I don't have a number of mole. I don't have a number of volume عشان اجيب المولز بتاعتها. بس احنا المره اللي فاتت قلنا I will imagine that I have the volume of 1. So let's imagine that I have a volume of 1 liter and 1 liter. Let's say like that. So number of moles of calcium is equal to C multiplied by V. What is the C, Mr.? The C is 1 multiplied 10 to the power of negative 3. And here sodium sulfate will divide in the same way, Na plus and SO4 2 minus. So this one will become 1 multiplied 10 to the power of negative 3, and 2 multiplied 10 to the power of negative 3, and 1 multiplied 10 to the power of negative 3, because the ratio is 1 to 1. Okay, so this is the number of moles of calcium, this is the number of moles of sulfate, this is the number of moles of sodium, and this is the number of moles of sulfate. So we'll have, now I will make the table of the ice table. Calcium sulfate forms calcium ions and sulfate ions. So this is solid, this is aqueous, this is aqueous. I did not start with anything here. This is 0 and this is 0. This is minus x, this is plus x, and this is plus x. Now, what is the concentration of calcium ions in the final solution, in the equilibrium solution? He said that it is x plus what? Sulfate يا مستر. Did you start with anything at the beginning in the sulfate? أنا already أساسا كان عندي sulfate solution before I add the sodium sulfate. أنا كان عندي أساسا sulfate solution وزاد عندي شوية. I have added some sulfate from the sodium sulfate. So I don't know how much I added. But I know that originally I have sulfate 1 multiplied 10 to the power of negative 3. اللي جت منين? From the original calcium sulfate solution. Here, what is the concentration of the calcium ions finally? I know that it will be the number of moles divided by the volume. The number of moles. كم عندك الكالسيوم اللي في الأيون من الأول؟ 1 multiplied 10 to the power of 3 باعتبار إن هو 1 liter. طب you said it is double the volume يا ياسين. So what will be the new concentration? Divided by كم? N over B. This is the number of moles.
Divided by 2.
Divided by 2, because the volume is doubled, so the concentration will be divided by 2. لأنه اعتبرت إن السوليوشن الأولاني 1 liter, and the new solution you said it is equal volume, it has an equal volume to it, so it will be 2 liters. So this means that the new concentration is divided by 2. So this means that you will end with a concentration of 5 multiplied 10 to the power of negative 4. So I can say that the sulfate ion remains the same, and it's a common ion, and the sulfate is common ion. Its concentration is the same here and here. أنا ما جبتش عندي sulfate ion من تاني. Then I will say what is the Q? Let's calculate Q is equal to calcium multiplied by sulfate. So calcium ions multiplied by sulfate ions, and he has given KSP is equal to KSP KSP is equal to 2 multiplied 10 to the power of negative 5. So this is the KSP, and then I have to multiply calcium by sulfate, so it will become 5 multiplied 10 to the power of negative 7 molar. And then I will compare this Q against K. This is 5 multiplied 10 to the power of negative 7, and this is 2 multiplied 10 to the power of negative 5. So this is less. So Q is less than KSP, which means that the reaction will go more toward the left, moves backward. So this is Q. Oh, sorry, moves forward because Q is less than KSP, so moves forward. And since this one moves forward, its solubility decreases, solubility increases, and no precipitate forms. مش هيعمل precipitate because I move to the right more. طيب, let's see another example. I have KSP of lead chloride is 1.7 multiplied 10 to the power negative 5 at 25 degrees. And find the molar solubility of lead chloride at 25 degrees. which is in solution of NaCl whose concentration is 0.1. So let's first write the equation. That's lead chloride breaks down into lead and 2Cl minus. And let's make the ice table also. I started with nothing from here, 0 here and 0 here. I decreased by x, I increased by x, and I increased by 2x. The solution concentration is originally having a 0.1 sodium chloride. So this is a strong electrolyte. The NaCl هيديني full ولا two way? It will give me a full. يبقى هيديني 0.1 sodium and 0.1 chloride. So this is the point كلها يا مريم. I'm saying that the solution will be having 2x. ماشي. لكن originally هو فيه ايه كمان؟ هو مش فيه الكلورايد اللي جايه من الليد كلورايد بس. ده فيه كلورايد جايه من الليد كلورايد in addition to the chloride that's coming from the sodium chloride. So this is the S, this is 2x. It's coming from where يا مريم? This is coming from where? From lead chloride. طب وفي الاول اساسا originally it has how much? It has some chloride coming from the HCl. HCl is a strong acid, so 0.1 gives you how much chloride? 0.1. So it will give me 2x in addition to this 0.1 chloride. What about the concentration of lead? He said the lead is to be, did he say equal volume? So he said the lead concentration will be KSP is 1.7 10 to the power of -5. So the information is plus x. This is plus x. So I will say that the KSP that he has given, who did not give me, he gave me KSP is equal to 1.7 في 10 to the power of -5 بتساوي ال x multiplied by 0.1 plus 2x. تعالى يا ياسين نقارن ال 0.1 بال 2x ديت. 0.1 multiplied with 2x. Which number is very big and which number is very small? This is a very big number, and what will be the number here? هيجي لي رقم تافه كده. So it's like imagining كده. Imagine يا ياسين so we can understand. This is a very rich person. Let's say anybody very rich. Let's come to Elon Musk and tell him you have how many? He said I have $100 million. Then I will ask him, okay, I'm gonna give you $100 more. And then I ask him next day, how much do you have? هيقول لي أنا عندي كام? He's going to tell me I have $100 million. هيطلع يقول في الجورنال I have or في الفيسبوك I have 100 million plus 100 ولا هيقول لي كام؟ هيقول لي 100 million برضه. So this number 2x relative to this number is almost nothing. عشان كده when I ask him what do you have? What is the concentration? Is it 2x plus 0.1 ولا أقول 0.1 وخلاص؟ I can just say 0.1 صح؟ Why? Because this number is very small compared to the 0.1 زي ما الرقم ده this number is very small compared to 100 million. فلما اديله 100 وهو عنده 100 مليون واساله how much do you have؟ هيقول لي 100 مليون plus 100 لا هيقول لي 100 بس. So this is the same. Instead of saying 0.1 plus 2x أنا هقول إيه يا ياسين؟ I'm gonna say multiplied by 0.1 بس. الله وال 2x رايح فين؟ لا ده رقم تافه جدا. I don't care about it. But don't forget that there is a square. Why is there square? Because there is a 2 here. يبقى أنا I will multiply the products مع بعض اللي هي ال x multiplied by 0.1 squared and then I will solve for x. X is equal to كام؟ It will come to be 1.7 في 10 to the power of -3. خلاص انت لقيت الاكس اللي هو الليد ال 1.7 في 10 to the power of -3 and then you have also the Cl minus. طيب طيب he's saying that I can also compare. انا خلاص طلعت ال solubility. This is the solubility. Again solubility هي ال X او ال S او ال concentration of lead. Solubility is the concentration, so S or the concentration. طيب can I ask about chloride برضو؟ ما chloride خلاص يا مستر احنا قلنا T 0.1 square. This is the concentration of 0.1 square. طيب let's see what is the concentration. So what is the concentration or what is if I have KSP if I don't have the common ion. يعني if I don't have the common ion لو انا عملت الايكويشن بتاعتي وعملت الاي ستيبل يا مريم من غير ما يكون عندي without I'm having a common ion. So this is my solution. Lead chloride forms lead and 2Cl minus, and I don't have sodium chloride اساسا في السوليوشن. I don't have sodium chloride. انا بس عندي الليد كلورايد. سو الليد كلورايد الكي اس بي بتقول عليه 1.7 في 10 to the power of negative 5. عايز الاقي السوليبيليتي يا مريم، عايز الاقي السوليبيليتي. احنا قلنا لو الريشيو 1 to 2 it's equal to what? Do you still remember it? If it is 1 to 2, let me write them again now.
4s
4s cubed صح؟
اه
تاني if the ratio 1 compound 1 mole is breaking into 1 and 1, or 1 is breaking into 1 and 2, and 1 is breaking into 1 and 3. This is which one of them, Miriam? It's 1 mole breaking into 1 mole and 2 moles. So this is 1 and 1 plus 2, 1 mole of lead and 2 moles of chloride. In this case ال KSP بيساوي 4s cubed، وهنا ال KSP بتساوي s squared، وهنا ال KSP بتساوي 27 s to the power of 4. طيب مستر لو انت عايز تجيب الاس، اس بتساوي راديكال الكي اس بي، اس بتساوي راديكال 3 of كي اس بي over 4، اس بتساوي راديكال كي اس بي على 27. So which one we need? We need this one. So s is equal to radical S is equal to radical 3 KSP على 4. هتطلع S بتساوي 0.016. طيب تعالى كده نبص ياسين على الاكس او الاس. انا المره دي سميتها اس واكس، هما الاثنين نفس الحاجه، هما الاثنين السوليبيليتي. هنا طلعتها 1.7 for 10 to the power of negative 3، وهنا طلعتها 0.016. So we are speaking about 1.7. So this one first time, this is without common ion. Without common ion. وهنا S is equal to 1.7 for 10 to the power of negative 3 اللي هي 0.0 كام؟ كده صح؟ 1 2 3 1 2 3 صح؟ So what happened to the solubility يا ياسين when there is a common ion؟ الكومن ايون بيعمل ايه يا مريم؟ it decreases the solubility. يبقى اقول له ايه؟ يا ريتك ما كنتش موجود، انا كنت عايز اعمل ديزولفنج للليد كلورايد في السوليوشن. لما اعمل له ديزولفنج في السوليوشن الكونسنتريشن بتاع الليد يا مريم هيطلع 0.017 0.016 سوري 0.016. لكن لما كان في كمان غير الليد كلورايد في السوليوشن في الاساس في صوديوم كلورايد، قلل لي السوليبيليتي خالص وخلاه لي 0.017. ليه يا مستر؟ because when you add it the solution C. ايه ده؟ انت بتحط لي Cl minus، انا مش عايز Cl minus، يلا اما اروح left. So it's moving mainly towards the precipitate, so it decreases the solubility. So what is the effect of the common ion? The common ion decreases the solubility. Decreases the solubility. Why? Because it's already this ion is commonly available, so it will try to decrease it, so it will form AgCl. طب لو ما كانش اساسا في ديت كلورايد الدنيا كانت هتبقى حلوه. سترونج الكترولايت NaCl بيديني Na بلس and Cl ماينس. تعالى يا سيدي نحاول نعرف ايه الفرق ما بين الايس تيبل هنا والايس تيبل لما بقى عندي كومن ايون. الفرق الوحيد هو في الجزء ده يا ياسين، الفرق الوحيد هو في الجزء ده. without the common ion انا كان عندي مين اللي طالع؟ ال 2x بس، ال 2x بس. طب مع الكومن ايون لا بقى عندي 0.1، بقى عندي 0.1. وانا بعمل الكالكوليشنز بتاعتي ياسين I ignore this x's. I ignore this x. ليه يا مستر you ignore this x؟ because this is a very small number compared للرقم الكبير اللي عندي بستهيفه. I will say this is a very small number. Okay, we'll have our last break, but this time it's only 3 minutes, and then we'll come back for some questions. Okay. Okay, first question, which of the following represents the mass action expression for the reaction N2O4 plus ozone give us N2O5? So in order to make this one, as we said, you can only include anything that's gas or aqueous solutions, but you cannot include anything which is solid or liquid. So this means that our product will be, what is our product? The oxygen gas concentration. And don't worry, gases can be Kc concentration or Kp pressure. يبقى الجازز تنفع الاثنين. I can be concentration or Kp pressures. Okay. طيب O2 and then divided by Y. I did not include N2O5 because it is a solid. and then I divided by the first reactant, which is N2O4, multiplied by the second reactant, which is the ozone. So this is our third option, the correct one. Right, next one. Which of the following represents the equilibrium constant expression for this one? Again, I will not include liquid also, no, and then solid also no. So the product is what? Only magnesium ions divided by the concentration of the hydrogen ions. And what is the power for hydrogen? It's 2 because it has a coefficient of 2. So I just put it as 2 here. Don't put the 2H Maritain. Don't put 2H and then put it 2 again. It's only the ions and then the coefficient you will put it at the product. So this is the correct answer. Right. Some carbon is heated in previously evacuated vessel in the presence of carbon dioxide. The following equilibrium is established. Final product pressure was found to be 0.74. Deduce the KP. So احنا قلنا المرة اللي فاتت يا ياسين واحنا بنحل we answered a question in which there is the total pressure. So let's write the equation. The CO2 forms 2CO. Where is the solid carbon? It is ignored. So what did you start with? He said I started with 0.60 atmospheric pressure. And how much you have here? I don't have anything at all. Then how much you decreased? I don't know. So it is minus x. And how much I increased? It will be plus 2x. Why it's plus 2x? Because the ratio is what? 1 to 2 ratio. So it will be 2x here. Now, what are the total products? The total products is the gases, carbon monoxide and carbon dioxide. The total of them is equal to 0.74. So this means that this one, in addition to this one, is equal to 0.74. So what is the equation here, Miriam? It's saying that the total pressure is 0.74. So 0.74 is equal to 6 minus x in addition to 2x. So 0.6 minus x. You said 0.6? 0.6, sorry, this is the change. So 0.6 is minus x. So it should be 0.6 minus x. And this is plus 2x, so this is 2x. So this is 0.6 minus x. كده مظبوط يا ياسين؟ 0.6 minus x plus 2x يعني equal to 0.6 plus x is equal to 0.74. So I can find x is equal to 0.14. Now I have 0.14. What is the pressure of CO2, Miriam? This is the pressure of CO2, so this is the equilibrium one, right? So what is the pressure of CO2? And what's the pressure of CO? انت قلت يا مستر البرودكتس, so it is CO pressure over CO2 pressure, and this has to be squared. هنحسب ازاي يا مريم؟
.6 minus 0.14.
So the products which is 0.6 minus 0.14, this is the product which is CO ولا 2x?
That's the reactants.
The reactants ولا products? I need to make the products are reactants or reactants are products? This is the reactants. So 0.6 minus 0.14 تطلع كام؟
0.46.
0.46. So I have what? And 0.14 squared is 0.28 squared divided by 0.46. Is it correct?
The answer is 0.17.
Okay, so 0.17, and I need 3 significants. So he has made 0.170. This is the same one. This is the continuity of it. Okay. Right. This one needs a little bit focus. Given the equilibrium reaction, I have A reacts to form 3B, and this is my K equilibrium. It's equal to X. And I have C plus 2D gives me B. This is K equilibrium is equal to Y. I need to find the K, the expressed in terms of X and Y, the K equilibrium of the reaction, which is a third reaction. A gives me 3C plus 6D. So let's please focus on this one. أنا عايز أجيب الإيكويشن. This is the equation that I want to find. A gives me 3C plus 6D. How I'm gonna do this? Mister, let's see the first part. So let's see the first part. What is the relationship between the, what did I do to the two equations? What did I do to the two equations? If you said here A gives me 3B, but what is B? B is B rex to form C plus 2D. Can I multiply this by 3? So in this equation, I will take out this P and put this one instead, but multiplied by 3. Then. So I will take out this one. So I will just take out this one. But this is 3P. عشان أخلي دي زيها. So to make this 3P in the same way, what you will do to make this 3P, multiply it all by 3. So multiply this all by 3. So it will be 3C plus 6D to give me 3P. So what do I need to do with this equation? هشيل كل دي. I will move this and put this one instead. So that's A gives me 3C plus 6D. So I reach it to this equation. يبقى أنا عملت حاجتين يا مستر. يبقى أنا عملت حاجتين. I added the two reactions together. So I added the two reactions together. لو أنت مش فاهم دي كويس, let's make it with the this one easier. S cycle. So this is A gives me 3B, and this is B is coming from C plus 2D. So I need to add the two equations to find the final equation, which is A to this one. So you have this one. What is the K equilibrium of this one? That's equal to X. And this one is equal to Y, but then you have to multiply it by 3. And you need to find this one. How do you find this one? The same like Hess cycle, you add these two together. So add this equation, to this equation, you will get the third one. So add this one to this one, you will get the third one, which is A into 3C plus 6D. So I multiplied this by 3. So it will be 3C and 6D. أنا عايز أجيب 6D. So I need to find the green one. Green one بتساوي الاثنين equations مع بعض. What did we say about adding the two equations? If I add two equations, في حالة K equilibrium, you don't add the values. What do you do for the values, Yasin? If I have equation 1 and equation 2,
multiply.
You multiply the values. So again, بص يا مريم, if I have two equations, in case of delta H, what do you do to get the third equation, the green one? You add them, right? You add them. Here, I don't add them. I multiply the values of the K equilibrium. So if you want to find the value of the third one, multiply the K equilibrium of the first one and the K equilibrium of the second one. يبقى ال K equilibrium بتاعت الأولانية هي X والK equilibrium بتاعت الثانية هي Y. The other one is Y. But take care, يا مستر. What did you do to Y, Yasin? What did you do to Y? Did you reverse it or you kept it? I reversed the equation Y. So I reversed the equation Y. So instead of Y, it will be 1 over Y. So it will be 1 over Y. And I did something else to it, كمان. I multiplied by 3. So if I multiplied anything by 3, the K equilibrium will be to the power of this number, so to the power of 3. So the answer is X multiplied 1 over Y over 3, which is equal to X over 1 Y3. Okay. So let's repeat again the three rules, Yasin. Let's repeat again for Miriam the three rules of the K equilibrium. If you play with any equation, the rule number 1 says that if you reverse an equation, what do you do to its K equilibrium? An equation, what do you do to its K equilibrium? It is reversed also, it's reciprocal. So the k new of the new equation that's reversed will be equal to 1 over the k of the old k. طب what is rule 2? If you multiplied by a factor, if you multiplied an equation by factor, the k new is equal to what? The k old raised to this factor. And rule 3, if you have 3 equations, if you add 2 equations, the addition will be by multiplying their k equilibrium. So this is k1 and k2, for example. So let's say k1 and k2 will be multiplied by each other. Okay. So this is a simple question about equilibrium. It's asking me how to know the equilibrium graph, and I must recognize the equilibrium graph in the exams. This is the one because at this one the concentration of the products decrease, the concentration of reactants increase, and then they become equal. Where is the point at which they become equal rates? This is the point. This is the line at which they will have equal rates. Okay, and we'll continue next time, inshallah. Okay, Mariam, you stay for a minute, please.
Okay, شكرا مستر.
شكرا يا ياسين. Thank you so much. Miriam, you were able to see the videos of the last sessions where they are? Were you able to see them?
Are they not on the YouTube channel?
No, they are on the link. So I'm gonna send you the link again now in case you missed it. Okay, and just please try to watch the videos, and if there is anything difficult, just let me know.
Of course.
Okay. Thank you so much. Thank you, Miriam. Bye.